Okay, so this is just a quick video which will help to support in exercise 9C question 13. I'm going to be doing a slightly different question, but the thought process should support you to answer your own question successfully. A car is travelling with constant acceleration in a straight line. It passes 3 e-scooter charging points, we'll call them A, B and C, and as it passes each of them, it has a changing velocity. As it passes A, it has a velocity of 10. As it passes B, it has a velocity of 30. And as it passes C, it has a velocity of 80 meters per second. We're going to call the time taken to move from A to B T1. And we're going to call the time it takes to move from B to C T2. Okay, so we've set out the scenario. I'm quite happy with what's happening or what's been described. There's constant acceleration. There's 3 points where its velocity is measured, and there's 2 time intervals. Okay, the question that we're being asked is to find the ratio of the times T1 and T2. The ratio of the time it takes to get from A to B compared with B to C. So the first thing I'm going to do is just to get some sort of visual representation of what's happening and what variables are going to apply to which part of the journey. So I'm just going to label these 3 e-scooter points, A, B and C. I'm not really trying to do this to scale, apart from the fact I know I was travelling slower at the beginning of the journey and faster at the end of the journey, so I assume there's a bigger gap in between B and C. But this isn't even really to represent distance. I'm going to put the velocities that we were travelling at each of those individual points, and I'm just going to show the interval which each time variable refers to. Let's start with journey AB. I'm going to go ahead and collect all of the SUVAT variables: the displacement, the initial velocity, the final velocity, the acceleration and the time. So I'm quite happy that the initial and final velocity for this part of the journey are 10 and 30. The acceleration was unknown, so I'll just call it A for now, and the specific time for this part of the journey is T1. Going to do a similar thing for BC. This time round, the initial velocity is 30 and the final velocity 80. Once again, we have an unknown acceleration, but it is the same acceleration as with the first part of the journey. So I will still call it A to be consistent. And the time in this case is T2. Okay, so what I want to point out here, 2 things. Firstly, the final velocity of the first part of the journey is the initial velocity of the second part of the journey, and the acceleration is constant throughout the whole journey. So that's why we have 30 appearing twice for 2 of the different variables, and A appears twice for the acceleration both times. Okay, in each of these, let's see if there's a SUVAT equation that would be useful. So V equals U plus AT looks perfect to me. That combines the 4 variables that we're working with. So for the initial part of the journey from A to B, I get 20 equals AT1. And for BC, we get 50 equals AT2. Well, both of these have the variable A. I think I should be able to rearrange to make A the subject, and then I can substitute that from one into the other. So if I label these equation 1 and equation 2, I'm then going to go ahead and substitute 2 into 1. Well, okay, I can write that out again, and I can just bring T1 into the numerator. So I get 50 T1 over T2. Let's divide by 50. I think you can see where we're going now. 20 over 50 equals T1 over T2. 20 over 50 simplifies. We can see that straight away. It's going to be 2 over 5. Okay, so I've got a fraction between them. Fractions and ratios are very closely related. I'm just going to change the form. To write it in ratio form, I get 2 to 5. The ratio of the time taken for the first part of the journey compared to the time taken for the second part of the journey is 2 to 5. In part B of the question, we're asked, or we're told, that if the initial part of the journey took 18 seconds, how long would the second part of the journey take? Well, here we're just actually rewriting our ratio, or I can just scale up the ratio. So I'll start by putting 18 underneath the 2 to represent the first part of the journey. And I'm thinking to myself, what is the scaling factor? What scales 2 up to 18? If I multiply by 9, that will be an accurate scale. And I'll do a similar thing on the right hand side. 5 times 9, 45. If I wanted to know the total time taken for the journey, I would add these together and I would get 63. The total time taken for this journey is 63 seconds.